Hello student, let us try to understand the dispersion forces or London forces because some of students were absent yesterday. So I'm trying to explain this once more. Dear student, try to understand. The atoms and non-polar molecule are electrically symmetrical and have no dipole moment because reason they are saying why they don't have dipole moment because electronic charge cloud is symmetrically distributed. What is meaning of this student? They are saying suppose that is molecule is there, this side molecule is there, so in the center there is a nucleus and that is electrons are there, that is which is surrounded this nucleus. So this is what student, this is the symmetrical. Okay, there is no positive negative charge is developing all the way, there is outside there is a negative charge. So this is what symmetrical, no symmetrical. And what is symmetrical means this is non-polar. Okay, no polarity develop plus minus on this molecule. Now what they are saying, next line you see, but the intermolecular forces may exist even this non-polar atom such as noble gases, non-polar molecule O2, N2, H2, etc. This is because the noble gases and non-polar molecule can be liquefied, suggesting that there must be some intermolecular attraction. In the other word, a dipole may develop momentarily even in such an atom or molecule. So what will happen student, in the same molecule, suppose these molecules are coming close. These molecules are coming close. So if these molecules are coming close, so one because of the repulsion what will happen student, one electron will be like that, all will be like that momentarily student, momentarily develop, and another case that is electron will go in the another direction. Okay, both the cases electron will move, that is which direction student, that is right direction, you see right direction. So it is the momentarily dipole is forming, and here is this is negative charge here at this side, that is no electron is the positive charge, there will be interaction student, there will be the interaction, and this interaction is known as student, this interaction is known as London forces. Okay, London forces, this is weakest type of forces, or we can say that is dispersion forces, or you can say dispersion forces, right student? Now try to understand another statement here. In order to understand the original origin of these forces, let us consider two noble gas atom A and B very close to each other. Each atom is uncharged because its electronic charge cloud is symmetrically distributed around the nucleus. Figure 1a. So you can see here figure 1a, this is they are saying uncharged because everywhere there is the symmetrical distribution of electron is there, so they have shown. Similarly, they are saying another statement. However, due to a motion of the electron, we can imagine that for a fraction of time, the electronic charge distribution in one of the atoms, say A, become unsymmetrical. That is, charge cloud is more on one side than the other side. Okay. So what is they are saying here? They are saying it is becoming unsymmetrical student. This is becoming unsymmetrical. Means what is electron is becoming right side and nucleus is one side. So here you see that is in one molecule there is dipole is being formed. Now read another statement. This is a very short period. The unsymmetrical centers are positively and negatively charged do not coincide. As a result of instantaneous distribution of electron in the atom, there is a small temporary dipole known as instantaneous dipole. So this is the dipole is forming, instantaneous dipole, more electron density on the right side. Okay student, these are the electron density like that here. So next point you try to understand, this instantaneous or transient dipole distort the electron distribution in the neighboring atom B, and induced dipole known as instantaneous induced dipole. So this instantaneous, what it does student, this repel the electron of this atom that is B, and that is all the electron gone down here. Okay, all the electron gone down here. So that is what is the induced dipole is of form in the atom B. Now let us see to the next line. Figure 1b. The temporary dipole of atom A, B attract each other. These attractive forces are also called instantaneous dipole and instantaneous induced dipole forces. Similarly, temporary dipole are induced in non-polar molecule also. Okay, this is the in the non-polar molecule. These forces of attraction were first studied by the German physicist Fridge, London, and therefore these are also known as London forces. These are also called that is dispersion forces. So this is origin of instantaneous dipole, instantaneous induced dipole, dispersion forces or London forces. So this is our answers. Thank you so much for watching, friends.